Okay, for this problem, we're going to do a one-star problem. Number 9 says a rod is lying on the top of a table. One end of the rod is hinged to the table so that the rod can rotate freely on the tabletop. Two forces, both parallel to the tabletop, act on the rod at the same planes. One force is directed perpendicular to the rod. It has a magnitude of 38 newtons. The second force has a magnitude of 55 newtons and is directed at an angle theta with respect to the rod. The sum of the torques due to the two forces is 0. What must be the angle? The description of what this thing's going to look like sounds really complicated, but it's pretty much just like a door. It's a rod that is attached to a table through a hinge, kind of like the way the door is attached to the frame of the building. So it kind of looks like if we draw out the information given to us, and we kind of draw the forces of the 55 newtons, and we keep that in mind that because it's at an angle, it has different components, the y and the x. And the hinge they're talking about is the thing that keeps the linear acceleration 0, so meaning this thing's not going to accelerate or fall to the ground. It's going to be allowed to rotate freely, but it's not going to be allowed to fall. Just like the door can rotate back and forth, but it doesn't fall down. The hinge keeps it there. So we want to find the angle of this 55 Newton force, and what we're going to rely on is the fact that the torque is 0, meaning the torque created by these two forces has to add up to 0. Now there is another force that we didn't draw at the hinge, because the hinge is going to counteract some of these forces so that your net force is 0. That way the center of mass isn't accelerating, but the hinge is not going to provide any torque because all the forces of the hinge are acting on the hinge, which would give it a distance of 0. So though there are forces on the hinge, they're not causing any torque because they're at the axis of rotation. But anyway, so we have a y component and an x component. We're pretty much going to ignore the x component because the x component is not going to provide any torque. If you pull on the door, it's not going to make it rotate in any sense. So when we do the net torque is equal to 0, we just simply take negative 38 newtons times however far it is from the hinge, plus F2y times however far away it is from the hinge, and it has to equal 0. We can divide both sides by the length that is unknown to get rid of that. So we get 0 is equal to negative 38 plus F2y. So the second force in the y direction must have a force equal to 38 newtons. So we use our inverse sine function using the hypotenuse and the opposite force to find our angle. And we calculate the angle to be 43 degrees or 43.70 degrees.